Welcome, YouTubers, to another episode in my Grammar Hero series. In today's video, I'm going to be discussing systems of linear equations that have one solution, infinitely many solutions, and no solution. As you can imagine, this is a topic that sometimes shows up on the ASVAB, and for that reason, I decided to cover it in today's video. Previously, I have uploaded 3 videos on systems of equations, and 2 of them I discussed how to solve systems of equations using the substitution and elimination methods. And in addition to doing that, I also discussed how to solve word problems involving systems of equations. In order to get the most out of this video, I strongly encourage you to watch those 3 videos if you don't know how to solve systems of equations already, and I'll place links to those videos in the description of this video. All that being said, however, let's go ahead and get started with today's video. All right, so to start today's video, let's review the definition of a linear equation, and then we'll go from there. So in short, a linear equation is an equation that has 2 variables, that is x and y, that produces a line when you graph it. So more often than not, linear equations are of this form: y equals mx plus b, where m is our slope and b is our y-intercept. So with that in mind, let's go ahead and solve this system of equations here. And then once we do that, we'll graph each of these linear equations as well as the solution to this system of equations and see what that looks like. So to solve this system in particular, I'm going to take this top equation and multiply everything by -1. Again, according to the elimination method, you want to multiply either one or both equations by a constant, such that when you add them together, one of the variables is eliminated. And as you're going to see in a few minutes here, we're going to eliminate the y variable in this case. So let's take this -1 and distribute it here, here, and here. -1 times x is -x. -1 times y is -y. And -1 times +5 is -5. Again, we're going to be adding that to the second equation, notably 2x plus y equals -4. Let's add these two together now. -x plus -2x is -3x. -y plus +y is nothing, so this variable is eliminated, equals -5 plus -4, which is -9. All right, to solve for x now, we're just going to divide both sides by -3. This crosses out here, leaving you with x equals -9 divided by -3, which is just +3. Again, a negative divided by a negative is a positive. Now that we've solved for x, we want to solve for y, and to do that, we're going to plug in this value of 3 into x in either of the 2 original equations. And as it happens, I think this top equation is pretty easy to work with, so that's where I'm going to plug it in. Again, this top equation was x plus y equals 5. We now know x is 3, so let's plug that in. 3 plus y equals 5. Subtract 3 from both sides. This leaves you with y equals 5 minus 3, which is just 2. So the solution to this system of equations is x equals 3, y equals 2, and of course you can express that as an ordered pair of 3, 2. All right? So now that we've solved this system of equations, we can see that there's one solution, but let's go ahead and graph these linear equations so that we can see exactly how the solution to this system and the equations of these lines are related. All right, now I'm going to do this in blue so it's a little bit clearer. Again, this first equation was x plus y equals 5. In order to graph this very quickly, we want to put it in this form, that is y equals mx plus b. So in order to do that, I'm going to subtract x from both sides. This crosses out here, leaving me with the equation y equals -x plus 5. Again, this 5 is our b here, which is our y-intercept. Let's go ahead and plot that. Again, the y-intercept is 5, which means the equation of this line impacts this y-axis right here at positive 5. Now, in order to continue graphing this equation of the line, we want to look at the slope. Again, the slope here is -1, so it looks like this, -1 over 1. And of course, you may remember that this is rise over run. In this case, this is a -1, so this is going to tell us to go down 1. And this is +1, so it's going to tell us to go to the right 1. So let's go ahead and do that. Again, we're going down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. And let me go ahead and draw a line there. Okay, there's our line. It's not perfect, but it's good enough. And let me go ahead and make these a little bigger. All right, let's do the same thing for this second equation, and let's do that in green now. If we have green as a choice, we do. Again, this equation is -2x plus y equals -4. We want to put it in this form, y equals mx plus b. So in this case, we're going to add 2x to both sides. This crosses out here, leaving you with y equals 2x minus 4. Again, our y-intercept is -4 here, and that tells you the point at which this line is going to impact this y-axis here. Specifically, it says it impacts the y-axis right here at -4. Now we're going to use the slope of this line to fill in the remaining points. Again, the slope of this line is 2 over 1. Again, that correlates to rise over run. So this says go up 2 to the right 1. So we're going to go up 2 to the right 1, 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 and up 2 to the right 1. All right, let's go ahead and draw our line through these points. All right, now that I've drawn both lines, what do we know about this solution here? It's 3, 2, so it's 1, 2, 3, 2. Here's the point, 3, 2. What do we notice about it? The solution to the system of equations that has one solution is the point at which both of these equations of lines intersect. So let's go ahead and solve this second system of equations. And I'm going to use the elimination method in an effort to do so. So I'm going to take this top equation and multiply it by a -1. Given that if I multiply this -1 to this positive y, and then add it to the second equation, the y variable will be eliminated. So we're going to take this -1 and distribute it here, here, and here. So -1 times -3x is positive 3x. Again, a negative times a negative is a positive. -1 times y is -y. And -1 times +1 is -1. Again, according to the elimination method, you multiply one or both equations by a constant such that when you add those two equations together, one of the variables is eliminated. So we've multiplied one of the equations by a constant. Now we're going to add it to the second equation here, notably -3x plus y equals -2. Let's add these together. 3x minus 3x. Well, that's nothing. That's eliminated. -y plus y is eliminated as well. So we have nothing on this left-hand side of the equal sign. -1 plus -2 is -3. So we have this statement, 0 equals -3. And that is an untrue mathematical statement. In light of that, we have to say that there is no solution to this system of equations. But that said, let's understand why by graphing the equations of the lines in this system of linear equations. So again, I'm going to do it in different colors so that it helps. This first equation was negative 3x plus y equals 1. We want to write it in this form, y equals mx plus b, so we can quickly graph it. To do that, we're going to add 3x to both sides. This crosses out here, leaving you with y equals 3x plus 1. We know this 1 is our b, which is our y-intercept. More specifically, that's the point at which this equation of this line impacts this y-axis here, so we know it's going to impact it right there. And our slope tells us how to fill in the rest of the points. Again, our slope in this case is m, which is 3. Again, we want to put that over 1 so we can use the rise over run to make the rest of our points. This says go up 3 and to the right 1. So we're going to go up 3, 1, 2, 3, to the right 1, up 3, 1, 2, 3, to the right 1. Likewise, if you wrote this as negative 3 over negative 1, negative 3 divided by negative 1 is positive 3. This says go down 3, 1, 2, 1, 2, 3, and to the left 1. 1, 2, 1, 2, 3, to the left 1. We have enough to make our line now, and let me go ahead and draw that in very quickly. Okay, that's our line for that one. Let's go ahead and do the same thing for the second equation now. And let's do that one in orange. Again, this second equation was negative 3x plus y equals negative 2. Again, we want to write it like this, y equals mx plus b. So we're going to add 3x to both sides. This crosses out here, leaving you with y equals 3x minus 2. And again, this negative 2's are our y-intercept, so we're going to go ahead and plot that point. Again, y-intercept's the point at which the line crosses this y-axis, and we can see that crosses right here at negative 2. And our slope is 3. Technically, it's 3 over 1, and we can use rise over run to graph the rest of our points. So we're going to go up 3, 1, 2, 3 over 1, up 3 over 1, up 3 over 1, and likewise we're going to go down 3 over 1. All right, let's go ahead and graph this line now. All right, what do you notice about these lines? These lines, as it happens, are parallel. So in other words, they're never going to cross each other, which means there's never going to be a solution to this system of equations. So whenever you're solving a system of equations and you have an untrue mathematical statement like this, that should be a clue that the lines are parallel and there's going to be no solution. What's another way you can quickly tell that these lines are parallel? Well, let's look at our two equations right here. Well, parallel lines have the same slopes. And the slope right here is positive 3. The slope right here is positive 3. So given that the slopes of these equations of lines are the same, you could have also saved yourself all this work and said, these are parallel lines, therefore they have no solution. Okay, so again, that's a case where there's no solution. Let's go ahead and take a look at the third example now. All right, let's solve this third system of equations. Again, I'm going to use the elimination method, which means I'm going to try to multiply one or both of these equations by a constant, such that when I add them together, one of the variables is eliminated. If I multiply this top equation by -2, we can see that this will become -2x plus 2x, which will eliminate the x variable. So let's take this -2, distribute it here, here, and here. So we have -2 times x, which is -2x, -2 times 2y, which is going to be -4y, and -2 times 4, which is -8. Again, according to the elimination method, we're going to add this to the second equation now, which is 2x plus 4y equals 8. Let's add these together. -2x plus 2x is nothing, so that's eliminated. -4y plus 4y, well, that's nothing as well, so that's eliminated as well. So we have 0 on this side, and we have -8 plus 8, which is also 0. All right, so unlike the previous problem where we had some whole value equal to 0, now we have a true mathematical statement, notably 0 equals 0. So in this case, we have infinitely many solutions. Okay, and to illustrate that, let's go ahead and graph these two equations very quickly so you can see what's going on here. I'm going to graph these equations in different colors so it helps us distinguish them. This first equation was x plus 2y equals 4. Again, I want to get y by itself, so I'm going to subtract x from both sides to start. This crosses out here, leaving me with 2y equals -x plus 4. And let's divide everything by 2 now. To get rid of it from here, this says y equals -1/2 x plus 4 over 2 is 2. Let's go ahead and graph this. Again, this 2 is our y-intercept, so it's the point at which our line's going to intersect this y-axis, and that's going to happen right here at +2. We can see our slope is -1/2, and again, that's rise over run, so let's use that to fill in the rest of our points. Again, I'm going to associate this negative with this 1 to start, and then to make more points, I'm going to associate the negative with the 2 down here, because those are the same thing. Let's go ahead and graph these now, and let me get my pen back. All right, so let's go ahead and graph this. This says go down 1 and to the right 2. So down 1 to the right 2, down 1 to the right 2, down 1 to the right 2. This says go up 1 and to the left 2. So up 1 to the left 2, up 1 to the left 2, and that is our line right there. So let's go ahead and plot it accordingly. All right, now that that line's plotted, let's go ahead and plot this second line. Again, our second equation was this. It was, and I'm going to do that over here, it was 2x plus 4y equals 8. That's right here. We're solving for y now, so we can have it in y equals mx plus b form. So we're going to subtract 2x from both sides. This leaves us with 4y equals -2x plus 8. Let's divide everything by 4 to get rid of it. This crosses out here, leaving you with y equals -2 over 4. That's the same as -1/2 x plus 2. Okay, and again, we can see that our y-intercept is 2 here. So the point at which this line's going to intercept this y-axis is right here. It's at 2. And our slope, again, is -1/2. And I'm going to associate that negative with the 1 to do rise over run. Then I'm going to flip-flop it and associate that negative with the 2 so I can do rise over run again. All right, so let's use this slope to fill in our points. Again, this says go down 1 to the right 2, 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 and this says go up 1 to the left 2. So up 1 to the left 2, up 1 to the left 2. Let's plot our line on the graph. Let me try that one more time. All right, so in this case, what did we have here? Let's look at our two equations of lines. They are the same thing, and as you saw, their lines are right on top of each other. So whenever you're solving a system of equations, and you're left with a solution of 0 equals 0, you should realize that your linear equations are the same equations, and therefore their lines are going to be on top of each other, and therefore there's going to be infinitely many solutions. Okay, so that's that one. All right, let's recap. So in this first example, when we solved our system of equations, we found an x and y value, which we wrote as an ordered pair. And as it happens, that ordered pair is the point at which the two linear equations intersected. In this second example, when we solved our system of equations, we had an untrue mathematical statement, which made us conclude that there was no solution. And when we graphed our linear equations, we saw that they were in fact parallel, so they'll never cross. And finally, in this third example, when we solved our system of equations, we had a true mathematical statement, notably 0 equals 0. Therefore, we had to conclude there were infinitely many solutions. And when we graphed our linear equations, we saw that the lines sat right on top of one another. All right, so that's it for this video. Let me just stress this. The goal of this video was not to show you how to graph an equation of a line. If it was, it would look much different. Instead, I wanted to quickly graph these equations of the lines such that you can see systems of linear equations with one, infinitely many, and no solution. So again, as you solve these systems of equations on the ASVAB, just bear in mind that there's going to be 3 outcomes, 1 solution, infinitely many solutions, or no solution. As usual, you're more than welcome to leave feedback in the comments section below. If you like the content I'm creating, please consider subscribing to my channel. But on that note, I'm going to go ahead and cut you loose. Konnichiwa.